Hi, welcome to the statics tutorials. So for this problem, we have a distributed load here that's a triangular shaped distributed load. Over at point O at 0, it hits a maximum of 25 Newton per meter in the middle of this 2-meter beam, and then it goes back to 0 over here. In addition, we have a 50 Newton load that's acting on this end at A, and then we have a 100 Newton meter couple moment that's acting clockwise or negative at this end at A. So we want to replace the loading, all of this loading, with a force and couple moment that sit at A. We'll have to take this in two steps. The first step, one, is just to find the total resultant under that distributed load and to find out where that resultant from the distributed load acts. Then from there, we'll do that final step and come up with an overall resultant and an overall resultant couple moment at O. So for this first step, we need to find the area under this distributed load. So this is a triangle, so the total area underneath is going to be 1/2 base times height. We have 1/2, the total base is 2 meters, and the height is going to be that 25 Newton per meter. So doing the math on this gives us 25 newtons, and then the centroid of this triangle is going to be right here in the middle. Oftentimes we're used to thinking of the centroid of the triangle as being 1/3 of the way, and it still is. It's just 1/3 of the way up, but since this is an isosceles triangle, the centroid is just right here in the middle. If you wanted to do this as two separate triangles, you could, and then you'd get the force was half of 25 on either side, so 12.5, and then the centroid would be shifted over here to be at 2/3 of a meter over, and you get the same result at the end. But I just used the one triangle here, got that x bar of 1 meter. Now taking it to the second step, we need to sum up all the forces and all the moments on our simplified system number 1. So sum of forces in the x direction gives us 0. Sum of forces in the y direction gives us this F1 of 25 in the negative y, and the 50 here in the negative y. So we have 75 in the negative y total. And then we have sum of moments about O. So we have our 25 from our distributed load here at an effective distance of 1 meter. That's giving us a negative moment. And then we have the 50 times the 2 meters length here, also giving us a negative or clockwise moment. And then we have the negative 100 Newton meters there at the end. Summing that all up, we get negative 225 Newton meters. And so now we can report that the moment is going to be a total of 225 Newton meters in the clockwise direction. And we can report that the resultant force is going to be negative 75 in the negative 75 in the y direction with units in newtons. Thanks for watching.